we now have a very simple test. And let's promptly go back to our data and see how the data values fall with regard to this test. Remember, we have a confidence interval, and now we can forget about everything else except how to compute the chi-squared and the confidence interval, which is from 1.69 to 17.01. And our question now is, where do the data fall in? So again, we start with this confidence interval, and now we compute the chi-squared values for first Burt's adult IQ data, second Burt's children's IQ data, and third, as a sanity check, for the random data that I generated on my computer for a normal distribution with these parameters. That is the third bar. And here is what we find. The chi-squared value for the parents, for the adults, clocks in at 0.13 for the given data. The chi-squared value for the children clocks in at 0.2. Both well to the left of the left quantile, 1.69. This is looking too good to be true. It's as if somebody cooked the books to make the numbers fall exactly where we want them to be. As a sanity check, take a look at the data that I actually generated using a random number generator on my machine. This is the third bar. It looks worse. It looks more aberrant, more fluctuations. Its chi-squared value clocks in at 10.07, smack bang in the middle of our 95% confidence interval. The level of fluctuations there is actually entirely to be expected. This is what real random data would look like. A certain amount of random fluctuation is inescapable, and this is very typical. But the data for the parents and the children, on the other hand, look too suspiciously good, do they not? But wait a minute. The story isn't quite done. And the reason is, this was based upon an assumption of a nominal sample size of n being 1,000. But bear in mind that Burt had told us that the three individuals in the higher professional category are actually more like 120. Perhaps there was a scaling factor of 40. Well, what happens if 1,000 is scaled by a certain scaling factor? Well, I don't know what the scaling factor is. Burt's paper doesn't tell us. So let's see what we can do if we posit a scaling factor. Let's say the sample size is 1,000 times m for some reduction from a sample to a mil, 1,000. Let's take a look at what happens to the chi-squared values as the scaling factor changes. And if we go back to our sum for the chi-squared, and we put in n is at 1,000 m, we find that all that happens is that the reported chi-squared values scales by m. Now let's take a look at what conclusions we can draw at a 95% level of confidence. What if m is 1? Then the chi-squared values are so excessively small, the data are just too good to believe. We reject the data with contumely on grounds that it is just too suspiciously regular. Fraud. What if, on the other hand, the data were actually scaled by a factor of 40? In other words, m is 40. In this case, 40 times 0.13 and 40 times 0.2 land us very nicely in the middle of the confidence interval from 1.69 to 17.01. In this case, the chi-squared values we get there are exactly what we might anticipate from just random fluctuations in data. Life happens. We don't always get perfection. In fact, we rarely get perfection in random data. And what if a scaling factor, this was not in Burt's paper, but what if there was actually scaling for between 10 and 20? That lands us near the periphery of the confidence intervals for both parents and children. In this case, we reserve judgment. Statistics can only do so much. Now, the point of this exercise was to show you how, in an unexpected way, central limit theorem arguments could lead to fairly sophisticated analyses of real-life situations. But real life is murky. Okay. We cannot at this stage look definitively at the paper. There's no other data available from that time of Burt. He is long gone. The people he surveyed, presumably, are also long gone. There's no way of testing that data. Right? The listener might want to think about the difficulties, perhaps, if we would accept the suggestion that the data size were actually more like 40,000. The difficulties of conducting 40,000 IQ tests for adults and 40,000 IQ tests for children, even over a period of 50 years. A very crude calculation would suggest that one will have to do something like 3 or 4 or 5 tests every day for 50 years. And you might want to ruminate on the difficulty of doing something like that on that scale. Okay. But then perhaps you might say, well, maybe he had help. But of course, these questions are all imponderable. And the attackers of Burt and his fervent defenders had different points of view on this. And to this day, the controversy still rages, right, with points of view on one side or the other. The point of our excursus was not to come to a definitive conclusion on whether Burt was more sinned against than sinning, whether he was really a great man who was unfairly maligned, calumny, or whether he was actually a lonely, embittered man who committed fraud in a desperate attempt to keep on to academic glory. No, such questions are far beyond our purview, and a statistical test cannot begin to illuminate these issues. But nonetheless, a principal test can provide a way forward, can shed some light on what is an otherwise a very murky business. Right? We don't need to just rely on faith. We can do some analysis. But we should keep firmly in mind the limitations of such analyses. To quote from T.W. Körner one more time, right? He urges us to keep in mind that battalions of numbers, like battalions of men, are not always as strong as supposed.